Hello, I'm Fernando Coleman. This is my textbook problem. What we have here is a beam, 5 meters long, 3 meters in X direction, and 4 meters in the Y direction. All we have is a force of 80 newtons applied in this direction, or downwards, with a theta of 37 connecting it to the beam. The only question we have is, what's the torque? So, it might seem challenging to figure out how to approach this problem, but I feel the easiest way is to just think, what are they asking? And they're asking us for the torque. So what do we know about torque? Well, we do have an equation for torque. That would be torque equals radius times perpendicular force. Okay, great. So now we know we need to find radius and perpendicular force. So let's look back at our initial problem. We have this beam here, and from first glance, because it's moving downwards, it might seem hard to find where the perpendicular force is. So let's just move it like this. Great. It's still the same thing. We still have the beam, we still have the force. But now we can see clearly that the 80 Newton force being applied in 37 degrees in correspondence to the beam has this highlighted force as its perpendicular force. So great, now we have the radius, 5 meters, and the perpendicular force is this one in yellow. All right. So for our final step, we look back at our equation. Torque equals radius times force perpendicular. Radius equals 5 meters. And now, from the old problem, we have this new triangle here, which says that 80 newtons to the theta 37 is going to give us this force perpendicular right here. So now we know that force perpendicular equals 80 sine 37. Therefore, torque equals 5 meters, the radius, times 80 sine 37. And by far the longest thing about this problem was the unicorn. I'm trying to draw a unicorn because I have zero artistic skill. Thank you.